Welcome to Meso-Scale patterns in gravity data for Eastern Australia and their relationship to fossil impact craters. This presentation is prepared as part of the research titled The Spatial and Temporal Distribution of the Metal Mineralization in Eastern Australia and the relationship of the observed patterns to giant ore deposits. We begin with a gray-scale gravity image of Eastern Australia. We then create a filtered median image. Note, with median filtering, the value of an output pixel is determined by the median of the neighborhood pixels rather than the mean. The median is much less sensitive than the mean to extreme values, called outliers. Median filtering is therefore better able to remove these outliers without reducing the sharpness of the image. This is the filtered median image for Eastern Australia. The median value for each cell has been determined using 60 cells, 60 pixels, in each direction, which are the neighborhood cells mentioned previously. Each cell is 0.9 of a kilometer on a side. This means that the median value for each cell was determined from 14,400 neighboring cells, and there are 15 million cells in this image. It took my computer 6 hours to create this filtered median image. The fine-scale features in the gravity data are revealed when the two images are subtracted from one another. The original grayscale image for Eastern Australia has the filtered median image subtracted. This reveals the fine scale features. This is the resultant map of Eastern Australia showing the fine scale features in the gravity data. The dominant wavelength is 50 to 80 kilometers. And we are well aware by now that the dominant wavelength of the Golden Network in Eastern Australia is approximately 80 kilometers. The locations of the cross-section lines in the fine-scale features in the gravity data for southeastern Australia. Note the symmetry in the north-south cross-section around the central high, gravity high, indicated by the yellow arrow. There is lesser symmetry in the east-west cross-section. This lack of symmetry was caused by northwest-southeast trending faults. The yellow arrows indicating the center of the gravity features in the previous slides is the proposed center of the Deniliquin impact. The Chicxulub impact site on the Yucatan Peninsula of Mexico. Gravity data reveals the near-perfect symmetry in this relatively recent impact that is 65 million years ago. Only meteors above a certain size, let's say greater than 10 kilometers in diameter, are likely to have any permanent impact on the mantle of the Earth. This is a reflection seismic profile of the Chicxulub structure. It seems likely that the structures shown here that are above the moho extend into the mantle, leaving a permanent template long after any superficial evidence has eroded away. This permanent accidental template in the mantle, consisting of concentric and possibly radial fractures, would impose those structures on any rocks that were subsequently laid down or emplaced over the mantle. Thank you, and please go on to the next PowerPoint presentation. References.